All right, so today's lesson is just a review of transformations. So we've studied transformations before, but in these couple examples, we're specifically looking at a cubic and a quartic parent function. So I can identify transformations of cubic and quartic parent functions. So your success criteria, step one is to identify the parent function. So let's talk about what these parent functions look like. Over here we have a quartic, so that would be f of x equals x to the fourth. That would be the parent function of a quartic. And it looks like this right here. That's the graph. This one down here is a cubic function. So f of x equals x to the third. And then this right here is the graph of the parent function. Then here's our graph here. All right, so I'm going to look at my given equation here. So this is the equation for this graph here. And I notice that it's an x to the fourth. So my parent function is a quartic. And the parent function is g of x equals x to the fourth. So then I want to determine, what do these other pieces mean? So that's identifying the transformation. So that's step two. Step one, we identified the parent function. Step two, we're going to swing on over here and review how to do that. How do you identify transformations? Well, if there's a number in front, that's either a stretch or a compression. So we have that 3 in front. So that could either make it stretch or compress. If k, so in our case 3, is greater than 1, that's a stretch. And if it's between 0 and 1, so it's a fraction less than 1, that's a compression. So it falls under k greater than 1, our whole number 3 greater than 1, so that's a stretch. Stretch by 3. Okay, now what does this negative 18 mean? Well, let's review our rules. There could be two things. It could either go right or it could go down. And the way we know when we have that case is it inside the parentheses or is it outside the parentheses? So I don't see any parentheses and it's outside, so that means it's outside. That means it's going to go down 18. And that would be called a vertical shift down. Okay. So that's my description there. Let's try another one. So look at this one. 5 times x minus 2 to the third plus 4. So first I want to identify my parent function. So the parent function is here, x to the third. And that's a cubic, graphed over here. And then, so I want to see, what are these other pieces doing? What is this 5? What is this minus 2? And what is this plus 4 doing to the graph? So let's start with the 5. The 5 is outside in front, and it's greater than 1, so that's a stretch. Stretch by 5. Minus 2 is inside parentheses, so that's going to the right 2 units. Or you could say a horizontal shift right 2 units. And then lastly, this plus 4, that's outside my parentheses, so that is this one right here, and it's going to go up k units. So up 4 units. So a vertical shift up 4 units. And that would be my transformation. Okay, so just a couple things maybe that we didn't hit here. So if you're adding inside, it's going left, subtracting inside, going right. Adding outside, going up, subtracting outside, going down. Negative in the front is a reflection over the x-axis, which we didn't see in any of these, but that is a possibility as well. All right, do the try it number 3. Pause the video, try that one on your own. So how does the graph of the function g of x equals 2x to the third minus 5 differ from its parent function? So first of all, I'm going to determine my parent function, which is this x to the third. That's the cubic function. So I want to see, what is that 2 do to the graph? What is that 5 do to the graph? So the 2 makes it a stretch by 2, and then it's going to go down 5.